Hi and welcome to lecture 2 of the lecture series ME 306 Advanced Manufacturing Technology. So we have already seen what a high velocity forming is. So in this lecture video, we will be mainly concentrating on different types of high velocity forming processes which are practiced in industry. Right. So this, as we have already seen, high velocity forming it can be classified into three types or three types of forming methods are there. Right. The first one is called the explosive forming method. Second is called electrohydraulic forming, and the third one is electromagnetic forming method. So from the syllabus point of view, we'll be concentrating mainly on explosive forming and electrohydraulic forming. So let us start our journey with this explosive forming method. Okay, so what is this explosive forming method? Now, as you all know, in a forming process, basically what we have is a punch and a die, right? You'll have a die, and the die will be clamping this workpiece, and then a punch applies the force, and this on application of this force, the workpiece takes the shape of the die, right? As simple as that. It is a very simple process, right? Now, this explosive forming is also similar to this normal conventional forming process. The only difference is that the punch is replaced by an explosive material. So basically, this punch is replaced by an explosive material. So as you all know, explosive material is something which produces explosion, right? Something that bursts, right? So same thing. So here, only thing is that we are using this explosion for a good purpose, right? So, explosive forming is a high velocity forming technique that utilizes chemical energy of the explosives to generate shock waves through a medium and use them to change the shape of a metal blank or perform or not perform, it is actually deform the workpiece. Okay, so explosive forming simply it's a high velocity forming technique, and it utilizes the pressure, the high shock waves which is produced on explosion. Okay, when it explodes, it produces a high shock waves, and this shock wave is used positively to change the shape of the metal. Okay, now how it is done? Let us analyze that. Right. So let us. So there are two diagrams you can see. One is before forming, and the other one is during or after forming. Okay. So your setup is something like this. You will have a chamber inside which you can find a die. Okay, you can find the die, right? And the die clamps the workpiece, right? And the gap between the workpiece and the die needs to be vacuum. So the air is sucked using a vacuum pump. The arrangement you can show it. You can see here, right? Now, as it is said, it's explosive forming, right? So you need to have an explosive, right? So the explosive is kept at some distance away from the workpiece, right? And the distance between the explosive and the workpiece is called standoff distance. It is called a standoff distance. It is not marked over here, but you should remember this, right? Now this entire setup is immersed in a medium which is a shock transfer medium, and normally water is used as a shock transfer medium, right? So the arrangement is very simple. Only you have a full chamber, a chamber inside which you have a die on in which is of the shape, which is of the required shape, right? And a sheet metal is clamped inside over the die, and you have an explosive charge, and every set in the complete setup is in a water medium. Okay, now then, now during the process, the explosive charge is made to explode or burst, right? So when this bursts, two things happens. Okay, I'll show you what happens. So when this charge breaks, as you can see from the diagram 2, when the charge breaks, two things happen. One is it produces a high shock wave, high pressure shock waves, right? At the same time, it also produces a gas bubble. You can see at the center there is a gas bubble forming, right? Now this shock wave is actually responsible for the deformation of the sheet metal, right? Now the shock wave makes this one too. It collapses with the uh, workpiece at a high. It produces a high impact, and due to this impact, this transform its shape to the shape of the die, right? Now at the same time, you can see a bubble forming over here. This bubble becomes large, and then it spills outside this chamber. Okay, so this happens something like this, as you can see from the diagram 3. Okay, to get a better view, let us see a video on the process. Okay, so what happens actually in an industry. Okay, so this is a video by the Ryan explosive formings. Okay, so let us try to see what exactly they are doing. Right, fine. Okay, now, so this is a sheet metal. It is in a particular conical shape, and this is inserted inside the die. Okay, so they are inserting that piece inside the die. Okay, the base part is the chamber inside which you have the die. Correct. So they have inserted that. Okay, and they're removing the top portion. Okay, now the complete setup is inside this one, and then it is made to burst. Okay, you can see that one, the water was spilling out, right? Now after bursting, okay, let us see what happens. This is the die inside which the sheet metal is kept. Okay, now let us see what happens. Sheet metal is kept. Now the die they are removing. Okay, they are removing the die. So let us see what happens once they remove the die. Okay, the die is being removed. Okay, so initially the sheet metal was of the shape of the same a conical shape. This one was kept inside, and after the process you are getting the particular shape. Okay, the die shape you'll get. Correct. So this is what is happening in an explosive forming. Okay, there are other examples too. You can see the material is kept, that the person one is keeping the work material which is of the conical shape, the desired shape material. You will get the desired shape. Okay, now after, so this, it has been transformed to a particular shape, as you can see from here. Right, fine. So this is explosive forming. Okay, I'll show you, this is a larger version. I'll show you a smaller version of this one too, right? So just see this video. So you can see this is a very small explosive forming equipment. It's a very small one, right? So let us see what this guy is doing, right? So this is a strip, is a metal strip which he is going to transform. Okay, okay, so this is the explosive forming equipment which he is having, a very smaller one. Okay, uh, now he'll be placing the explosives. Okay, so he is taking the explosive. Now the explosive is kept in between, right? It's kept in the space. Okay, so you can see that. Now the material which is to be transformed is kept in between, and then in between the die and the other pieces kept over there. Now he'll tight this complete setup. Okay, so you can see he is tightening, and then the complete setup is closed, right? Now the explosive burst using this the hammer. When he beats this setup using a hammer, what happens is the explosion happens, and due to this explosion, the material transforms its shape to the new one as per the die. Okay, so this is a very simple apparatus or simple equipment which demonstrates this explosive forming, right? Now I hope you guys might have got a good idea about what is explosive forming, right? Now, this type of the whatever we have spoken of, or the this type of explosive process is also called a standoff technique or unconfined type. Okay, so it is called standoff because the explosive is kept at some distance or at some standoff distance from the workpiece. It is not at contact. There is a standoff distance. Therefore, it is also called unconfined or non-contact type or a standoff technique. Right. Now, we have seen there are three phases happening over here. One is the setup phase, followed by the explosive is detonated, then the shock waves forms, and then uh, it deforms. There are only three phases are happening, or three processes are happening in this one. Okay, so this describes the process. What we have done, we have already explained how the process is happening. Okay, now the complete setup is kept in a water medium. There are many things which water helps. One is it absorbs the shock, it prevents the sound, and also the water medium gives a uniform distribution of the pressure, right? Now, when the pressure pulse impinges against the workpiece, the metal is deformed into the die with a velocity as high as 120 meter per second. As you can imagine, that is very high velocity, and the transformation is happening. Okay. Now, this process is a versatile process. That is a large variety of shape can be formed, and there is no limit to the shape. That means any shape material can be formed using this method. Only thing is that all you need is a large die to produce this component, right? And even for low quantity production, this method can be used. Even for high quantity production or low quantity production, this method can be employed, right? Fine. Now, as I said, we've been dealing with the standoff technique. That's one type of explosive forming. So obviously there will be another type of explosive forming. Okay, so the explosive forming can be uh, can be divided into two types. One is the unconfined type or the standoff technique, which we have already seen, and the second one is the confined type or the contact technique, right? This one is the standoff technique. There was no contact between the explosive and the workpiece. The second type, it is having a contact. Okay, so that is called a confined or a contact technique. So let us see what a contact type technique is, right? Now, in as you can guess, it is nothing but there will be a contact, right? In contact type, explosive charge is detonated while it is in contact with the workpiece. Obviously, it is in contact with the workpiece, right? Thus, there are differences in the energy requirements and mechanical behavior of the workpiece, right? So the explosive is kept in the form in a cartridge. We'll see that in the figure. Okay. Now the detonation produces high pressure up to 30,000 megapascal. Right. Now this process is mainly used for bulging tubes. We'll see in the figure. See, this is the type of arrangement. Okay, here a cartridge. You can see a cartridge. This cartridge will be inserted inside this one to the point. See, normally this method is used for making bulging. Okay, see, you can see the thickness over here, the cartridge thickness. It will be in contact with this material, and it produces this bulging. Okay, another thing is that cartridge will be inserted, and then it is made to explode. And due to this explosion, what happens is the material, this is a workpiece material, the one in orange color is a workpiece material that will deform and take the shape of this die. Okay, so that produces a bulging, right? So it is mainly used to create this type of bulgings, right? So this is the contact type, right? So these are the basic types of explosive forming. Okay, now let us move on to what are the basic advantages of this explosive forming. So from this process itself, you can identify most of the advantages, right? So one of the important advantages is that you don't need multiple process, just a simple one shot process, right? It is exploding and you will get the shape, right? So the component is generally formed in one shot. Okay, that is a great advantage, right? And only one die is required. The other one is the explosive, right? There is no punch or the male and female part, both are not required. Only one die is required. The remaining action will be done by the explosive. So this reduces the tooling cost, right? And the ultimate strength and yield strength is improved. No, it's due to high velocity forming. It is a particular it's a peculiarity of the high velocity forming is that it automatically improves the yield strength and the ultimate strength of the material. Okay, and the probability to damage the work is less, and large and thick plates can be formed, and it is economical. Okay, so since it is economical, even it can be used for production of low quantity of products as well. Okay, so these are the advantages of explosive forming. So as usual, it also will be having some limitations, right? And the main limitation is that vacuum is an essential part. Therefore, adding it to vacuum pump and all, it can increase the cost. Okay, now dies must be larger and thicker with to withstand the shocks, right? Now it is not suitable for small and thin work. Okay, and the important limitation is that since explosive is being used, you should get the permissions from the higher authorities, and all those things, all those legal issues will be there, right? Now the basic applications, it is used in almost all areas, almost or core areas it is used. That is for sheet metal panels, jet engine parts, missile nose. Okay, it is having a particular shape. It can be used to shipbuilding, radar dish, etc., etc., right? So those are the applications, right? Now, as I said, the water is used as a shock absorbing medium, right? Now, and the other from another important function is that it ensures the water ensures a uniform transmission of energy. Okay, and the other advantages are common, right? It muffles the sound, that is, it reduces the sound of explosion and all because it's a water medium. That's okay. Now, going to the process variables, even this you can assume itself, right? The process variables. So process variables are something which is affecting the process, right? One of the thing is the type of explosive, right? Depending upon the type of explosive, you will get different type, right? A different output, right? If the explosives is not that much heavy, or the energy produced by the explosives not that that much, means uh, the profile that you are getting will not be that fine, right? Now the second one is standoff distance, SOD. That is the distance between the standoff distance is the distance between the explosive to the work material. Okay, it should be optimum, right? And the medium to transmit is water, and the other important one is work size, and the obviously work material properties, vacuum of the die, and all other process variables. Okay, all these things affect the process, right? Okay, now this is it. This is all about the explosive forming method. Okay, now let us move on to the next type, which is electrohydraulic forming. Okay, or EHF, or it's also called the electrospark forming, right? So this is the diagram for the electrohydraulic forming. It is more or less similar to the explosive forming. Only thing is that instead of explosion, we are using spark. Okay, we are generating spark using using electricity, right? Since it is called electrohydraulic forming, right? So for that, let us see this first figure. Okay, you have a power supply and that is connected to a capacitor bank. Okay, so as you all know, the capacitor will get charged, right? And when the switch is on, a high discharge will be going to the electrodes. There are two electrodes over here, and this electrode will generate a high spark. Okay, and due to this spark, what happens is it generates high pulses, okay, of high pressure, and obviously that high pressure pulses will impinge with the workpiece. You can see the workpiece over here. Other setup is same, okay, and the workpiece will transform its shape. Okay, now one of the advantage or the disadvantage, okay, depending upon the application, it can be an advantage, or the disadvantage is that with this, it will not get converted in a single shot. Okay, the energy produced by this spark is uh, less compared to what is produced by the explosive forming. Fine. So what happens is you need multiple process, or multiple sparks needs to be generated to produce the final shape, depending upon the shape. Right. So in a way you can adjust the spark, and in a way you can adjust the process as well. Okay. So since it is not happening in a shot, you can adjust the entire process. Right. So you'll get a better idea with the second diagram. You can see that spark gap is over, the spark is produced, and shock wave is produced by this spark, and that waves on impinging with the workpiece, it transforms the shape. Okay. The remaining arrangements being the same. Fine. Now the same process is explained over here. Uh, and here the voltages range from 10,000 to 30,000 volt is applied uh, to produce the spark discharge. Okay. Now the energy produced, as I said, is less than that is produced by explosive forming. It is usually necessary to repeat the process several times to get the desired result. Fine. Now the basic advantages of this one is that the cost of tooling will almost always be less than the conventional equipment. It is compared with the when it is converted with a conventional method. Okay. Now the large amount of energy can be directed into isolated areas as required in some piercing operations. Okay. Now the better control of the pulse. Okay, since we are using electrical method, you will get a better control. And remaining basic advantages: it is safe in handling. It is safer in handling than the explosive materials, right? And when it comes to explosive materials, you need different permissions and all. There is no need of such things for electrohydro forming method. Okay, and it is more suitable if the work size is small and medium, right? The process does not depend on electrical properties of the work material. That's it. Okay, now the basic limitations are that one of the significant limitation of the process is that the energy rating of the capacitor bank and the amount of energy which can be dumped by triggering the device is another, right? So the capacitor's capacity is one of the important limitation in producing the, but as we have already spoken of, in a short it is very difficult to produce a component. Okay, now materials having critical impact velocity below 30 meters per second are not practical for electrohydraulic forming. And that's it. Those are the basic limitations, and it's suitable only for smaller works, right? Vacuum equipment is more complicated, and the standoff distance is necessary for effective process, right? And similarly, it is also having the same process characteristics. One is the standoff distance; it must be optimum. Then the capacitor used, as we all know, the energy must be optimum, right? And the transfer medium, usually water is used. Vacuum must be proper. Material properties with regard to the application of high rates of strain, right? Now, the basic application is mainly used in aerospace industries and to produce bulging, forming, beading, drawing, blanking, and piercing operations. Okay, so this is it. This is it. These are the basic applications of this process. Okay, so in this lecture video, we have seen two different main methods for producing uh, high velocity forming. Okay, we have seen what explosive forming is, and then we have also seen what electrohydraulic forming is, right? Both the process differ very little bit in the generation of the waves. That's it. Remaining things are fine, are same. Okay, so thank you one and all.